Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video, this is part of the 100 Days of Rust and Go video series, and this is day number 4, or video number 4. And in this video, what I want to do is focus on is we're going to talk about the other data types. So in the last video, we talked about declaring variables, and I kind of went into what an integer is, but there are other data types. So we're going to go into those and talk about sort of like how do you switch between variable types and typing them and whatnot. That's going to be sort of the focus of this video. So we're going to start with Go, as usual. Okay, keep it consistent. Okay, so let's see here. Let's go to the actual Go documentation. Like, my favorite part of the Go documentation is this tour of Go section. It makes a lot of stuff fairly clear. But here are like the main types. So you have bool. Okay, so that's going to be like an if or an else. So think like if I were to declare a Boolean variable, it'd be like var we'll say b equals bool, and that's going to equal false or true. Okay, nothing too crazy there. True means true, false means false. I don't think there is necessarily this. It's not like in JavaScript where you have the idea of like truthy and falsy, so you'd have to like convert things into true or false. For the most part, we'll test that out as time goes on. We'll get the conditionals, but there's true and false. Then there is, let's go back. Okay, there is string. Okay, this is going to have an actual string type, which we'll see Rust. It gets a little complicated with the whole string deal, so we'll be spending a few videos on that. Okay, var. So we'll say var s string, and then this equals a string cheese. Okay, and then I can kind of stick them in here in the string here. Percentage v, and just say num bs. Okay. Oops, wrong terminal. Boop. Go run.go. Now assign to num3. Oh yeah, that's right, because we were showing you reassignment in that previous video. So let's get rid of that. num2 declared but not used. Okay, let's not then. Hello, 1 false cheese. So see if we can use those values. Okay, going back to the different data types. We talked about like the different strings. Okay, like you know, what difference between signed and unsigned integer, difference between like 8-bit, 16-bit, 32-bit. Okay. Then there's a byte. Okay, a byte is at the end of the day really just a unsigned 8-bit integer. Okay, 1 computer byte. Okay, but you have that as a type. Rune is interesting. What it does, it's for dealing with like Unicode. So if you want to sort of specify like what Unicode value you're looking for, you can do it by using what's called a rune. We'll explore that later on. Like, this is one of those things I do want to kind of get better with. Floats, again, floats are just numbers where there's a decimal point, so there's a floating point. So again, they can be stored in either a 32-bit spot or a 64-bit spot. And then complex, I'm assuming, is just some sort of like complex scientific notation. Probably nothing I'll have to use anytime soon. Okay, so those are the main types within Go. Okay. Now, one of the things that you always have in a language is sometimes you need to convert a one type of variable to another. So I might have like the number 42, and I might want to turn it to a string, or I might have the string that has the number 42, and I might want to turn it to a number. Okay, this is always referred to as casting a variable. Okay, if you've done Python, you're probably very familiar with casting. In JavaScript, they have type coercion, so you oftentimes don't have to do it because JavaScript will kind of figure it out for you, which leads to some interesting results, which also opens the door to some really interesting patterns. But let's take a look. How do we cast in Go? Casting in Go. No, not in Golf. In Golang. Okay. Here we go. Let's see how we do that. Okay, yeah, that's what I figured. It's basically every type has its own sort of like constructor function. So you can just pass the variable you want to convert. So basically, so let's see this. Let's see. Var num string. Let's do this. Num string, which is going to end up being a string. equals a string that we're going to create out of num. Okay, so basically, again, num is a number, and we're going to use it. So I'm going to create another print, fmt dot print line. Okay, and we're going to print num string and num, and see if we see a difference. Okay, num string and num, and no, it didn't print. It did not successfully turn num into a string. Interesting. Let's see, did I read that right? I guess you have to specify string. Let me do it the other way around. Okay. I guess for the number types, there's the constructors. Do we have convert into string golang? Figured it'd be. Don't tell me it's going to do that atoi function. Yep, that's what I thought. Okay. Itoi stands for integer to a, like a string. So I means I have to import another library called string conversion. So basically, those types that you just saw a second ago for converting, like that, doesn't necessarily do what I need to do for string specifically. I need to bring in this library called string conversion. I always forget about that. So basically, now I want to bring in multiple libraries. If I remember right, we can do this in a parentheses, and then I just specify the different libraries I want to bring. Strconv. Okay. So now what I can do is this. It would be string conversion dot etoa, and then I would pass in num in there. Let's see, that should work, unless I imported it wrong. So num type in as a type in argument to string into did I think about that wrong? 3. That's right. Strcov itoa. Cannot use type uint. So what if I just pass in the number 1? Does it let me do that? So there's just something about, yeah, it looks like it's just something about unsigned integers. Okay. What if I made that just a normal signed integer? Would that work? Let's explore. This is how you learn more. By having a hypothesis. So it's not the integer. Okay, so as I could look, again, I could read the documentation, but I like kind of like figuring these out, experimenting a little bit, because this allows you to kind of like see where the barriers are in a language, which allows you to kind of understand where the barriers are a little bit more. So let's see here. If I make this a 32-bit integer, does it let me do it now? Okay, what if I just change it to an int? Does it let me do that? Got it. So this has got to be a standard, and it can't be a typed int. Okay, what if I did 64? Let me do int 64. Nope, has to be an int. Got it. So let me see here. If I do this uint 8, so let's go back to the uint 8 integer. But let's say I convert this back into an int like this. Does it let me do that? Int. Actually, maybe that's lowercase, if it exists. Int. Yep. Okay. So this converts it into an int type, and then I can convert that into a string. So again, you need this library, string conversions, to do like conversions in strings. And we're going to spend I was planning to do just like 1 day on strings in both languages on these kind of things. So I'm not going to spend go much deeper into that. Okay, so I think that's a decent exposure to like the different types of things we go. Let me just see if there's anything else I really wanted to touch upon. Okay, we talked about casting. We talked about short variable declarations before. Type conversions. Oh, that's right there. Okay, type inference. Again, that's with like the walrus operator. Okay, so we've done that. 0 values. So these values are like the 0 or the, hey, if the thing doesn't exist kind of value for those types. So 0 for numbers, false for Booleans, and an empty string for like strings. I don't think that's anything too new if you've done any programming before. So moving on to Rust. Okay, Rust gets a bit more complicated. So let's go over to the Rust docs. Okay, first let's just go to the list of types. Okay. Where did I see the list of types before? Okay. Well, once I go there first. Bottom line is, where did I see it? Custom types, structures, no, primitives. Here we go. Primitives. So these are sort of the basic scalar types, which will represent like a particular value. So we kind of mentioned before that there's different integers, so like I8, I16, which means a signed integer, U8, U16, which means unsigned integer, and then for floats you have F. So similar to Go, except you're not typing in float or int, you're just typing F or I. Now a big difference though is that there really isn't a string. Strings are a little bit more difficult in Rust. So the basic, really the true type is char. Okay, so there's a type called char, which represents one character, and they actually represent a Unicode character. So they technically are kind of more similar to the runes in Go in a sense. But yeah, so you can store like emojis in them, the whole sort of deal. Okay, you have Booleans. And then you have a unit type, which is just really just supposed to be like empty. It's just an empty tuple. Okay, it's just supposed to basically represent like nothing. Okay. Cool. Compound types, we're going to do a separate video there. Okay, but let's talk about like casting. We'll just try some of this stuff out. So types, casting, again, converting between types. Okay, here instead what they do is they have an as keyword. So for example, let's say I want to create a variable called string or s, which is a str. Str technically is a string type that's in there, but it's really an array of characters and doesn't really have any built-in methods. So if you work with strings in JavaScript and it has all these like really cool methods that you can do cool stuff with, that's going to be more the string struct in Rust, which again we'll cover eventually. Okay, so a string is just really going to be like a array of strings, an array of characters. An array of characters, again, you can't really change the size. There's not going to be really much you can do with it other than use it kind of as a string. Okay, so in this case, let s equal, and let's just see if I do this. If I do 45 as str. Okay, and let's see if it lets me do that. And then let's see if I can inject s into. Okay, so see here, let's go switch over to the Rust terminal. So the idea is I'm taking, I want to change num as a string. And let's see here. So I'm trying to convert that number into a string that I can then use as a string. Okay. Oh, that's right, because in Rust we have to use the colon to type. So it's like that. Okay. And still doesn't like it. Using a box or reference that's appropriate. Cast to unsized type integer as string. Let's just see here. Read the errors. I love reading the errors in Rust just because they give you so much information. So let's see here. The size and values of type string cannot be known at compilation time. Okay. So this has to do. So since strings are technically an array of chars, and essentially arrays can't be dynamically sized. You can't like sit there and say, okay, hey, this variable is going to determine the size of this array. It has to know how large the array is going to be from the get-go. Same thing with the string. It has to kind of, you always have to give it a value right up front. So really what I need to do is I am going to have to use this string struct, which is not going to quite let me do it. Let me just see how they have an example of that as a car. So yeah, I can do like one conversion rules like. So yeah, you can't convert the car because again it would create an array, and do they have an example of doing it to a string? And again, this is going to get to also the underlying reason why like strings work differently in Go, because at the end of the day, like strings aren't a thing. Like we see a bunch of letters and we're like, yeah, that's a thing. But in programming languages, really there's a series of Unicode or ASCII codes that are put into an array that represent the characters that are in a particular order. So in that case, it kind of is under the constraints that an array would be. And in a low-level language, arrays require sort of a sequential chunk of memory. So you have to kind of declare them up front, because you can't dynamically like do that. Okay, for the memory to be sort of allocated efficiently. Like we'll have vectors later in Rust, and we'll have slices in Go that are going to allow us to do some more dynamic allocating of data, but under the hood they work differently than what a true sort of array does. Okay, and again, strings are just arrays of characters or arrays of Unicode or ASCII codes. Okay, so in that case, really probably what I'd have to do. Okay, so in this this can only really be used for like numbers per se, or certain situations, but you can use it for casting. Okay, what I want to do is create a new string struct and say string from. Okay, let me see. Does it let me just do it from a number? Let's try that out. Okay, but this is now no longer. I have to change the type to a string. And again, a string is not necessarily a scalar type. It doesn't represent one piece of information. It's actually a special struct type. Okay, and I think generally with structs, once you start getting into these more complex object types, this isn't going to work for us anymore. Okay, so if I want that S to appear, okay, I need to do something a little bit special. I need to put like a colon question mark, and that allows it to like unpack it because it implements a particular trait, which we haven't talked about traits yet. But the idea is that all objects in Rust have certain functions available to them based on whether certain traits are applied to them. So you have these object types, structs, and if they have a shared trait, they can all share certain functions. Means there's a version of that function for that, and we'll get deeper into that. But the idea is that most of the built-in structs should have a trait called debug that allows you to print it by using this little thing here. So let's try that out, see if that does what I think it should do. So like typing wise, I did type it as a string and I'm giving it a string. This means make a string from whatever I passed in. So let's see, does it do what I want it to do? Okay, yeah, I figured the from might have a type error. Okay, the trait from is not implemented for, from receiving an integer. The following implementations were found. Yeah, so I have to take it from a string. Okie dokie. Let's see here. Let's see here. Do they give us a as car? Car, they're able to do that, but you can't do a float. So let's see what happens if I do like number as car. But technically what I'm passing in is not a string then. Like I could do this like maybe one as car, just like a one character number. Let's see what that does. Okay, gave me a warning. Get in there. But in that case, since it's now a scalar type, I could just do this again. So that's why I gave me like the slash u, like hello world, and then now nothing shows up. Okay. Let's see here. Variable num is assigned but never used. But I could pass a car. Let me just actually try passing num as car again. Yeah, only a U8 can be cast as a car, not an I32. Got it. So they got to be signed integers. Okay, and specifically only a signed 32-bit integer. Okay, and that was casted as a 8-bit integer. So what I have to do is say num, let's try this if I can compound it, num as I32, because that's what Rust is telling me, saying, hey, that should be an I32, so let me cast it to an I32, and then cast it to a character. Let's see if it lets me do that. Okay, only a UA can be cast as a car, not I32. Oh, but I read that wrong, backwards. So it's a U8, that has to be. So I cast it to a UA and then to a character. Does it let me do that? It does. Doesn't show me, it doesn't interpolate, right? So let's try this. What if I do that? Show it to me now. Okay, 1E. Not quite what I wanted. This is what I was expecting. Okay. But that's a thing you can do, but I don't like the results of that. Is there a better way to cast a string? Convert number to string in Rust. Okay, strings always make things a little bit more difficult, so you have to let's see here. Yeah, so I guess two strings still works. Okay, so that means it's just saying that the string. So then what I can do is I say num dot to string. That should be a method that's implemented on a number. So let's see if that works. Hello world 30. But num, oh, that's right, because we reassigned it. So num is 30. Okay, so that worked. So that will allow us to cast a number to a string. So there is a method that allows us to do that. So that's good to know. Okay, again, I'm not a very regular Rust programmer, so that's the reason why I'm doing this 100 days. This is 100 days of code for me, is just as much as it is for you guys. Okay, but I think that's kind of covered the stuff I want to cover. Like there's some other topics here, like literals, and essentially all this is just saying is you can do some interesting stuff to double or change the size of the memory that's allocated. Okay, by adding like prefixes on your typing. Okay, suffix literals. Their types are unknown at initialization. So the idea is I'm saying, hey, like it's this, and then here we don't know what the types are, but it's implicit based on the value. Inference, and again, this is just kind of getting the idea that if I don't specify a type, if I assign it a value, it will determine the value based on the thing that I assign it to it. Aliasing. Okay, and then here what you can do is you can create custom types. So you can use this type name to create aliases if you have a hard time remembering like U64, or if you just need something that's going to be that, but you don't want to use U64 because you want your code to be more explicit, you can create like a type. So in this case, they're using U64 for nanoseconds and inches, but they rather say inch to make it more clear what it is. So they create like a type that just equals another type. They alias it to make their code more semantic. Okay, so that's kind of in there. We just talked about conversion, but let me see. Are they going to go into anything else? Into, from, and into. Okay, yeah. So here are some traits. And again, what I told you, like some traits allow certain functions to be built into the thing. So they're saying that here that there's a from trait and an into trait, where you can make something from something else and turn something into something else. And then certain types have that trait, which means they're going to have those functions. Okay, so that will, I'm going to save off until we get to traits a little bit later on before I get too deep into that. But I think at this point we've learned a little bit more about the different data types available in these two languages, kind of where strings kind of play into that, how strings fall into that a little bit. We'll be spending a lot of time with strings. It's always where like a lot of the nuance is, and we'll go from there. I'll see you all a little bit later on. Have a great day and enjoy.